Okay, let's talk about concentrations, which are really different ways to express the relative amounts of solute in a solvent. Okay, and so what we're going to do here is give you different units of ways to measure concentrations. So first, let's talk about relative or qualitative terms. Okay, when something is relative or qualitative, it means I don't know exactly how much there is, but I can give you like an approximate amount, okay, or relative to something else. So these are words like dilute and concentrated. I don't really know how much there is. I can just tell you that there's more or less of the solute compared to something else. So this isn't very useful for most circumstances because it doesn't give you like a number for how much stuff there is in there. So most chemists don't really like terms like dilute and concentrated. Okay, instead, they prefer a little bit more quantitative description. Okay, and so for example, maybe we use solubility, which is based on how many grams of solute I have in 100 milliliters of water. Okay, it could be any solvent and any amount, but typically the solvent is water, and typically the amount is 100 milliliters. So imagine if you had a container that had 100 milliliters of water in it, okay, and I'm going to dump in my solute. Maybe it's sugar, okay, and I keep adding more and more and more and more and more sugar. Eventually, the sugar doesn't dissolve anymore. And when it doesn't dissolve anymore, I've reached the limit, which is called the solubility limit. So if I'm under that amount, this is going to be called an unsaturated solution. If I'm at that amount, then it's called a saturated solution. And if I'm actually over that amount, then I call it a supersaturated solution. You say, wait, if it's a limit, how can I ever go over the limit? Well, what I didn't tell you is that these solubility limits are actually functions of temperature. Okay? As I increase the temperature, the solubility also increases. Okay? And so imagine the same situation I had before with my container, and I have a saturated solution. Okay? So there's as much sugar in here as possible at that temperature. Okay? Then I heat this up on a stove or something. As I heat it up, the molecules are expanding, so there's a bit more room for solute to go in. Okay? And so at a higher temperature, what used to be saturated is actually unsaturated. So I can add a little bit more solute to it. So now I dissolve more sugar at the higher temperature, and I create a saturated solution, and I heat it up and add more, and heat it up and add more, and heat it up and add more, and do this kind of gradually. And then when I slowly cool it back down, all of this extra solute, in this case sugar, that I added to the solvent, in this case water, will temporarily remain dissolved, which is called a supersaturated solution. But it's not very stable. So if I just disrupt the system a little bit by kind of shaking it or moving around, kind of looking at it funny, that's going to cause all of this extra solid to just kind of precipitate to the bottom. So it's not a very stable situation, but it could exist for a short period of time. So now let me show you some more numerical ways, quantitative ways, to measure concentrations. There's something called percent by mass. And so the percent by mass is useful if the solute is a solid. And percent by mass basically means just take the mass of the solute and divide by the total mass of the solution. And we're going to multiply by 100% to get a percentage. Something similar, percent by volume, is used if the solute is a liquid. We're going to take the volume of the solution and divide by the total volume, volume of the solute, and divide by the total volume of the solution, and then again multiply by 100% to get a percentage out of this. Okay. The main difference between percent by mass and percent by volume is here I can say that the total mass is just the mass of the solute plus the mass of the solvent. For volume, I can assume that the total volume is the volume of the solute plus the volume of the solvent. But it's not exactly equal to that. It's going to be approximately equal to that. But we will assume that volumes are additive. Okay, the two most important units of concentration for chemistry are molarity and molality, right? They sound very similar, so you have to be careful how you pronounce these things. Okay, molarity with an R is equal to the number of moles of solute, N, divided by the volume of the solution in liters, right? Total volume of the solution in liters. Molality with an L has the same numerator, right? Moles of solute, but this is going to be the mass of just the solvent in kilograms. Okay, so to distinguish between molarity and molality, we use different letters. Molarity is capital M, which is usually italicized or kind of tilted a little bit, and molality is lowercase m. Another unit that you might come across later for things like colligative properties is mole fraction. And the definition of the mole fraction of something is how many moles of that thing do you have divided by the total number of moles. Okay, and so we're going to take the number of moles of A, which we're going to call the solute, but it could be anything, and we're going to divide by the total number of moles of everything. Notice that the mole fraction here has no units, but it has to range between 0 and 1. Right? Mole fraction of 0 means that there's nothing of that in there. Mole fraction of 1 means that it's 100% that substance.